Hi, today we'll solve this problem, which basically says that we have a sphere, a hollow sphere, is half of its volume submerged in a certain liquid of a density of 800 kilograms per meter cube and has an inner radius of 8 centimeters and outer radius of 9 centimeters. So the problem says that this part is submerged, so half of its volume is submerged, and also says that the inner radius is like that. But as we know, the most common units to use are in meters, so we only have to convert this into meters. Well, now that we have this, the problem is asking us for two things. The first one is the mass of the sphere and the density of the sphere. So now that we have the values here, we have to recall the formula of the buoyant force. So we know that the buoyant force represents the displacement of the water removed. So the buoyant force is equal to the density of the liquid in which is on the object, and times the volume times the gravity times the volume, of course, of the object. And also we have a counter force, that is the weight of the object. So the mass of the sphere times g. And since we know that these two vectors are equal, we can make this equal this equation. So the density of the liquid times the volume of the sphere times the gravity equals the mass of the sphere times the gravity. And now that we have this equation, we can get the mass from here. We already know the density, they are given as the density, and the volume we can calculate it, and these g's are the same, so this one could pass dividing, so these may cancel. And the volume, we only have to calculate the volume of a sphere, which is 4/3 times pi r cubed. So since we are interested in the half part of the sphere, we want the whole volume of this part, even though the problem is saying it's hollow. Since we are only interested in this part, we'll only have to isolate m and substitute this r in this r. We'll have to replace that. And this is capital R because we're taking into account the whole volume of this half of the sphere. And since it's a half of the sphere, we have to add this half into our equation, since we are asking half of the volume. Half of the volume. And you only have to substitute the values.
The density, 1/2 equals like this, 2/3 pi r cubed. In meters, we have to take your unit.
And in order to prove that this equals the mass, we have the units. M to the third cancels with this m to the third. So we only get kilograms. And this will might give you 1.22 grams is the mass of the sphere. Now the second question is asking us for the density of the sphere. So we know that the density is equal to the mass over volume, but in this problem it's a hollow sphere, so we have to do two equations out of one. We know that the volume of any sphere is 4/3 times pi times I squared, but in this case we'll get 2. 1 with this r, the outer radius, this radius, and the one with the inner air radius. So we only want this part of the volume, so we only have to subtract this to this. So in our equation it will be something like this. See, I only took out this part because it's a common factor, and there is the subtraction, and this is, we already have the mass. I erase it. Now we only have to substitute these values.
1.2 kilograms over 0.09 meters, and then 0.08 meters squared.
And this may give you this value. And if you want to check out if your answer is correct, you always can go back to your equation and check the units. Here you have m squared and kilograms, so there are kilograms, m squared. It doesn't matter if they are subtracting each other. With units doesn't work like that. You only have to count these ones. Only they cancel out if they are dividing. So we have m squared here and kilograms here. So then there is the density of the sphere.